Okay, today's video is section 7.5 in Algebra 2, how to apply properties of logarithms. There are four main properties you'll use. The log of a product is equal to the sum of the logs, and that makes sense. Remember, the answer to a log problem is an exponent, and if you remember, when we have x squared times x cubed, what do? We add the exponents, x to the fifth. So it makes sense that if our answer is in exponents, we're going to be adding them when formally multiplying. Likewise, the log of a quotient is equal to the difference of the logs. The log of a value raised to a power, I can bring that exponent straight down front. This is one of the most I find this to be one of the most useful properties of logs, and you'll see how that comes into play later. And in addition, we have this change of base formula, which says the log of any base of some number can be equal to the quotient of the log of the value over the log of the base to any common base. And we use that a lot because our calculators store log base 10 and the natural log base e. So if I'm looking for the log base c of a, I can just write that as log base 10 of a over log base 10 of c and put that in my calculator, or ln a over ln c and put that in my calculator. I like this one because you don't have to write so much. And again, you'll see how that comes into play later. So these are the four properties. You really want to have these available to you. I have a lot of experience with them, so I can easily remember them. You want to be able to reference them, so have them in your notebook or have that part of the text available to you as you work through the problems. In the first set of examples, they give us some values. Log base 6 of 5 is approximately 0.891. Remember, what does that mean? 6 to a number less than 1 is 5. That makes sense. Log base 6 of 8. 6 to a number a little bit more than 1 is equal to 8. And we're going to use these two approximate values to evaluate some logs. So again, what if I wanted to know what should I raise 6 to get 5 over 8? Well, that's pretty tricky, but if I use the properties of logs, I can write this quotient as a difference. Log base 6 of 5 minus log base 6 of 8. And up here I have approximate values for that. So 0.898 minus 1.161. And that's approximately equal to negative 0.263. And it makes sense that I would have to raise 6 to a negative number because I'd need to want something over 6 to get a number less than 1. How about log base 6 of 40? Well, we know that that number has to be a little more than 2, right? Because 6 squared is 36. But again, we can write this as log base 6 of 5 times 8. And then 6 of 5 plus log base 6 of 8. And then we have approximate values for those, 0.898 plus 1.161. And so that value is approximately 2.059. Again, 6 raised to a little more than 2 will give us 40. And then two more using those values. Log base 6 of 64. Well, remember I had log base 6 of 5 and log base 6 of 8. So the best thing I can do with this is say this is log base 6 of 8 squared. And then remember the property of log says I can bring that 2 right down front. And then I got to approximate because my value for log base 6 of 8 was approximately 1.161. And so I get an approximate answer of 2.322. And again, 6 cubed is, 36 times 6. So that's way more than 64. So again, I'm raising 6 to something a little more than 2 to get 64. And so likewise, how can I write this? I can write this as, remember all I had was 5 and 8. So I can write this as log base 6 of 5 cubed. 3 comes down front. And then I substitute my approximate value of 0.898, and I get approximately 2.694. So that's how you use those properties of logs. Now you can use them to expand or condense So here I'm going to expand a product and an exponent. So this is log base 10, remember, but since it's a product, I write that as log 3 plus log x to the fourth, then that